Hi everybody. Here's a quick walkthrough to the LabFlow experiment entitled Introduction to Laboratory Measurements. So when you click into this folder in LabFlow, you'll see the first item is a PDF file, and this is going to explain to you your purpose for doing the lab, the procedure, kind of all of the details that you'll need to understand why we're doing this. So first thing you'll want to do is click on this PDF, but before we do that, I'm just going to show you the format of LabFlow. Below that, there'll be several videos. As you can see here, one of the videos is about graphing things in chemistry in the lab. One is about using a balance and the different types of balances. One is about volumetric glassware, which will be discussed in this lab. And one is about micropipettes. This is typical for LabFlow. You'll see the PDF at the top. You'll see a collection of additional materials, be they videos, sample data, pictures, whatever it might be. Then you'll have a pre-lab quiz, which you must do before you can finish the actual assignment. And then an introduction to laboratory measurements report. So for each one of your labs, you're going to have a quiz and the report. First thing you'll want to do is click on the PDF. And when you do that, it'll open up in a new tab. Up at the top here, you can pop this out to a new tab. And I recommend doing that so that you can have it sort of on the go, ready to look at. The PDFs in LabFlow will all look kind of like this. They'll have the purpose up at the top, in this case, making different sorts of measurements and analyzing that data via a spreadsheet. They will give you a list of learning objectives that should be included or outcomes from this work, the skills that you'll do, and then equipment. The thing I'd like you to understand here is that LabFlow can be used in a number of different ways. One of them is that this might be a pre-lab or an introduction. This might actually be the piece of paper you would print out and take into the lab with you, and you would do the procedure that's coming up in the next steps. The way that we are using it in this online course is to do the online portion of this, and I'll show you what that looks like in a minute. You should read through the procedure for each one of the labs as you're doing them. Read through the procedure first. So the background reading in this particular one is about precision, error analysis. There are some bolded vocabulary words that are described here. Some data that the writing talks about, and the formulas and things that you might need as you go through the actual experiment. There are sometimes some additional link outs here that are sort of enrichment. Not required that you follow those, but enrichment so you can, expand the scope of this work. If you keep going, and pardon the quick scrolling here, but if you keep going, you will see lots and lots and lots of examples and data and equations, things that you don't want to miss, right? So make sure you're looking at the PDF first. You then will see a section entitled Procedure. This is the procedure that you will do for the lab. Now, being that we're doing the lab online, what you're going to see is that the lab itself will provide you with the data as if you had made these measurements. I'll show you what that looks like in a minute. But the procedure would say that you would get a set of objects in this case, use these tools to measure the dimensions, length, width, and height, and then measure the mass. Then we'll do a section on volume measurement. Then we'll do a section a little bit further down on data analysis. They walk through the steps here on how to do the analysis that you'll be asked to do in the lab. So you'll want to read through, and they tell you step by step how this works. Everything here is referencing Microsoft Excel, which you do have access to through the school, through the Office 365 program. You also could use Google Sheets or any other spreadsheet program that you like. It doesn't matter, whatever you're comfortable with. Then you go through, towards the bottom here, they'll go through all of the examples, the analyses. You will be using this table, which I'll point out again later. And then towards the bottom are the actual data tables. Now, I like to have an idea of what the data table looks like here, because when you see it in the online version in the report that we're going to look at, it looks a little bit different. All the pieces are still there, but the format's a little bit different. So in this particular case, remember our first section was measuring the dimensions and masses of different objects that we would have picked up in the lab. And so here, object A would have had a shape, either a rectangular prism or a cylinder. And we're being asked to measure our dimensions, 3 of them for a rectangular prism, length, width, and height, only 2 for the cylinder. There was a diameter and a height, and then the mass. And so you would have measured these and written down all of your information in the lab. In the online format, you'll be typing in the information as you see it in the sample data. Down here, we've got the second section of data where you would have recorded things, then the data analysis, and then a few questions. Okay. And then the procedure is done. The PDF is over. I'm going to keep it open just so that we can refer to it later on. So we go back here, we go back into LabFlow, and what we're going to see now, you would hopefully watch these videos so that you understand what's going on. The pre-lab quiz is here, which again, you will have to complete before you can go into the report. I don't have to because I'm the instructor and I can cheat. When you click on that report indicator, you will go to something like this that says the experiment can be completed in person or completely online. How will you collect data? I hope that this is a self-explanatory choice, but you will choose virtual. Next. And then we'll start into the actual data entry collection. Okay. What I want to do in this particular video, as it's the first lab report we're looking at for LabFlow, is I want to go through in really detailed steps and point out the things that you'll want to pay attention to in LabFlow as you go forward. Okay. So I clicked virtual here. Most of the labs will look just like this. Some of them will ask you if you want provisional data. That's different language for the same thing. Okay. So either way, you'll pick the option that's not in person and enter that. And now we're going to read this. So the first section, remember this was the first section of our PDF, dimension and masses of solid objects. They say, use the images provided below to collect data virtually. If you have technical issues, contact support. Fair enough. If you do ever need to contact support, please email me to let me know that you're having an issue, but I can't actually help with any of the technical behind the scenes issues in LabFlow. What I can do is give you an extension on the lab if you need that so that you can get it worked out, but you're going to contact support from this little kebab menu up here and hit the support button. Okay. They say here, report your measurements with the correct significant figures. So you're going to be learning about significant figures in the course. You'll want to apply that here. I often get the question, when do I need to use significant figures? And the answer is anytime you've measured something. So if you're doing a measurement or you're doing a calculation, you want to pay attention to how you report that data. And that's described separately in our lesson on significant figures. Step 1 from the procedure here in the box. This is taken from the PDF. Obtain a set of objects, cylinders, and or rectangular blocks that are the same material. Record the density of the material. And then you have been assigned set number 8. Enter the identification number of your set of objects. Now, imagine you're in the lab. You've walked over to the bench, the materials window, whatever it is, and there's a whole collection of things there that you could choose from. You're going to pick something up, and you have to tell me which thing you picked up. So in this case, enter the identification number right here. It's number 8. Okay? So literally just put an 8 in that box. LabFlow does this often in labs you'll see going forward. When you're being assigned something or there's a choice, oftentimes the choice, the result, the answer will be right above the question. So pay attention to that. It's often simpler than it seems. So set number 8, I'm going to put an 8 in that box and go forward. Now the system knows which set you're dealing with. They say record the density of the objects, and it's right here. Okay, 0.750. Now never put units in these boxes. Okay, they tell you over here what units you should be recording your answer in, grams per cubic centimeter in this case. But in the box, you're just going to type the number. Okay, 0.750 because they told me that right here. I'll hit next. Now, the next steps of the procedure, record the shape and then measure it, and then measure the mass, and then repeat. So we go down. Here's object number 1. Is that a block or a cylinder? Well, it's a cylinder, so I'll put in number 2. 2 cylinder. It says enter the number corresponding to the shape. That's a cylinder. Now, measure the diameter. So this is a measurement tool now. We've seen here that we have this ruler going across the diameter of the circle, so right through the center. Notice that it is already lined up for you precisely at the beginning, and then we go to the end. This is where measurement comes in handy, and if you had read through the PDF, you would see that anytime we're using an analog device like this, we need to measure what we can see and then estimate one additional decimal place. We do that anytime we're using an analog device. So this particular ruler that they've given me is marked every 1/10 of a centimeter. Right here, centimeters, I've got 1 and 2. It's marked every 1/10. And so the answer that I record will be recorded to the 100th place. That's the 1/10ths I can see, and I'm estimating one more digit. So here's 1, there's 1.5, 1.678. So now you get to estimate that last digit. I don't think that's exactly on the 8 line, so I'm going to say 1.81. Okay, now you might think it's 1.80 or 1.82. That doesn't matter, but it does matter that I've recorded it to the appropriate precision, 2 decimal points, because my ruler is marked in single decimal points. All right, the number that you put in here will be used for your data calculations and results later on. So it doesn't matter if you estimate differently than I did. What matters is that you've entered the data to the correct level of precision. We go on. Now we have to measure the height. We've turned the cylinder on its side, same ruler, 2.6 something, 2.64, 2.65. Again, you get to estimate that last digit, but it's definitely between 2.6 and 2.7 right here. I'm going to say it's halfway through. Okay, there we go. Now, is there a third dimension? No, because this was a cylinder, and the procedure said for a cylinder, only enter 2 dimensions, diameter and height. So they tell me right here, enter zeros for that third dimension. Okay, we go on. Now, what is its mass? So I scroll down, here's a digital piece of lab equipment. This is a digital balance. Now, digital balances come in a couple of different designs. They are typically a trade-off between high capacity and high precision. So this one is representative of a pretty typical top-loading balance. We have the little pan on the top. We've put our object on it. The balance would have read 0 when it was empty, and now it's reading this. Now, anytime we have a digital device, we are going to record whatever that device tells us. So this marks our mass in 5.172 grams. That's what I'm going to record. I'm not going to round it. I'm not going to add any extra zeros, whatever it is. I'm going to write down what is on there. So for analog devices, you read what you're marked plus estimate one more digit. For a digital device, you just record whatever is provided for you. As a result, maybe you can sort of see here already, my mass is going to be more precise than my dimensions, my distances. Okay, we click on. Now, object B, also a cylinder, so also number 2. And diameter, again, let's do this, 1.5678, 1.8, that one looks a little bit bigger to me, 1.8, I don't know, 3 maybe. Go on, let's measure the height, 2.5, maybe 5.5. Okay, again, that last digit, the value isn't tremendously important, but its presence is important. And this one's a cylinder, so I enter zeros. Okay, I'm going to skip ahead for a moment to the volume section. Now here we go, I've just finished up my last mass and distance measurement up above, and now I'm at the pipette delivery section. So this is the beginning of the volume part of the lab. First, I'm measuring water temperature. This is an analog thermometer. So again, analog rules apply here. This device, if I look carefully, is marked every 1 single degree. I've got 10, 11, 12, 13, 14, 15, up to 20. So I'm going to estimate my precision to the 10th of a degree. It's marked every 1. I'm going to estimate to the 10th. Now, I think that's 19.9. It's not quite to the 20 line in my mark, so I'm going to say 19.9. If you did think it was right on the 20 mark, what you would do is write 20.0. Okay, that trailing 0, that 0.0 is important because that's telling our reader that our device was actually marked to the single digits, and I'm estimating a tenth. Okay, I would not want to just put 20, because that implies that my device was only marked every 10, and I think it was right on the 20 line. Right? More detail in the significant figure section of the chapter in the reading, but that's how you would handle it. Make sure you have the right number of precision digits. I'm going to say 19.9 because I think that's what it reads. We continue. So again, in our steps, preparing a mechanical pipette, there's a video about how those work. They deliver water in a very precise way. I'm delivering water into the beaker, and I am taking its mass. So 3.972 is showing. Now I do it again, right? This was the beaker with water in trial 1. This is trial 2. Not quite the same number, but pretty close. I'll record that one. Trial 3. Right, we're going to repeat this multiple times because we're going to average the results and do a little statistics later on. All right, so we're going on and on and on. Now I'm going quickly here, but you want to make sure that you're typing these numbers in correctly. It will give you an opportunity at the very end of the data entry section to check your numbers, and you can scroll all the way back up to the top and check all your numbers. In my experience, it's a lot easier to just make sure they're right as you go along. Make sure you didn't type something in backwards or whatever. So here's the end of the data entry section. You can review the entries or proceed, and they say your results in the next section will be based on what you just entered, so make sure it's right. All right, we can click review if you want to change anything here. I'm going to click proceed. All right, so we go on to the results and calculations. All right, now what it's going to do is now show you collected your data virtually, and here is all of that data. I had set number 8, the density was so on. These are all the numbers that I put in earlier. This is the water temperature that I measured. Here's all those masses. Now, here's the analysis part. This is taken out of the procedure as well. These are all those equations that I scrolled through earlier on. They're going to tell me the formulas for calculating volume of a cylinder or volume of a block. And so you have your data here, your equations there. And they're going to tell me I'm going to do this in a spreadsheet, okay? So whether it's Excel, whether it's Google Sheets, whatever it might be, you're going to use a spreadsheet. And they tell you very specifically. So do this, label a new column, put in all the information. So you'll go through and you'll calculate your volumes, you'll calculate your coefficient of variation, absolute and percent errors. And then they're going to ask you to put in your answers here. Okay, so you can type in your answers. They show it by default in a table view, which I kind of like because it matches what you would see in the procedure document. You can also click it to a list view where everything has its own little box down below. I find this confusing because you have to then make sure you're filling in the right box. So either way you want to do it, punch in your data here, punch in your results here, and then there's a couple of questions, little free response thing, a few more questions. What I want to show you is at the very bottom, if I scroll, sorry again for the scrolling, if I go to the bottom, you'll see some file upload spots. Now, the purpose of this file upload portion is to, well, twofold. One, to document what you've done so that I can see what you've done, and particularly if you have run into a problem or you've gotten a concept wrong in the upper part and you email me and say, Dr. Stamper, I don't understand why this wasn't right, whatever it is, I can go and look at your data. I can look at your writing. I can look at your calculations, and probably I can figure out quickly what you did wrong. The other reason for this is an academic integrity reason, so that I can see that you actually did the work, that you didn't just copy somebody else's data. Now, it should be that LabFlow is tweaking around the numbers for each one of you, so nobody should have exactly the same numbers. But that said, it does add something to see it written out in your own hand. So in this particular case, they're asking for several different things. Upload a spreadsheet for the dimension, mass, density part. Separately, upload a spreadsheet for the pipette delivery part. And then thirdly, upload your report sheet and or notebook pages. Now, I don't care how you upload these things. In my particular case, if I were doing this, I would probably have one spreadsheet that had two different tabs on it or two different sections on the same sheet. So I might not have two files here. In this particular case, for me, you can upload the information to either of these or to both of these, and it doesn't matter. As long as I can find your dimension mass stuff and I can find your pipette delivery stuff when I look at it, it doesn't matter if you've uploaded them as one document or two. It also doesn't particularly matter to me if you upload it as an XLSX file, the Excel file, or if you save it as a PDF, or if you take a photograph of your screen or a screenshot and upload that. As long as I can see what you've done, it doesn't matter. This is particularly important if you're using Google Sheets. You can export from Sheets as an Excel file, and you could upload that. You can also export from Sheets or print from Excel as a PDF, and you could upload a PDF here. Again, doesn't matter as long as I can see both things that are being requested. This notebook pages one you'll see on practically every lab that we do. And in this case, again, you might have some written stuff that you wrote out. That might be calculations, that might be equations, that might be where you were recording things on the PDF if you printed that out and recorded on it. It doesn't matter exactly, again, so long as I can tell that you've done the work. So if you didn't print anything out, that's fine. If you wrote on notebook pages, that's fine. If you kept your data digitally on your spreadsheet and just have the spreadsheets to show for me, that's fine. So basically here there are 5 points altogether between these three prompts. If I can see your dimension, mass, density material, and I can see your pipette delivery material, you'll get credit for all three of these, regardless of how you've uploaded it. Now in later labs, we might be doing something that requires a bit more writing out of calculations. Maybe you're not doing a spreadsheet, but you're going to do a bunch of math and calculations and writing. In that case, I would like to see some sort of an upload of your notebook pages. Again, that could be a scan if you have a scanner available. It could be a photograph with a smartphone or a webcam if you have that kind of technology. Just something to document to me that, yes, you did the work and that I can see what you worked on. So it helps both in the academic integrity sense and it helps in the troubleshooting stage later on. When you're all done and you've entered all of these things and you've uploaded your files, you can click Submit. It's going to tell me I, of course, have not submitted everything, and you'll click that Submit button. Now, for the lab, you've got one attempt, so I'm going to cancel here. If you don't get through all of this all at once, you can just exit. And as long as you haven't clicked that Submit button at the bottom, your work will be saved but not submitted, and you can continue it later in the week. If the due date comes and you have not yet finished, the labs are programmed to lock automatically, and then whatever you have completed at that point, you will get credit for. Now, if something came up and you need an extension for whatever reason, typically, as long as it's not becoming a habit, we can accommodate those sorts of things. But just shoot me an email, let me know, and I will get back to you on that. Okay. So that said, you're going to see the same sort of format for all of the labs we do this semester. PDF at the beginning, that's super important to read. The video or sample data or pictures or whatever it might be in the middle that's going to explain things. And then a pre-lab quiz and the report. If you have questions, run into problems, anything like that, please do let me know. I'm happy to try to help you out with that. If it's a technical sort of an issue, there's a couple of things I want to point out here in this first video so we're all on the same page. Firstly, there is a support menu over here. And when you do that, they're going to say, how can we help you? And then there's some knowledge-based stuff that you can search, whatever it might be. Things that you might end up having trouble with are listed here.